So the only new thing today, we had talked about variables and constraints. The only new term, well, I guess there's two new terms, but the only new term that we're going to introduce is the objective function. So I'll walk you through what the objective function is in this first example, but basically it's what you're trying to optimize. So for example, this first problem, it says 3 teams are traveling in cars and minivans. Each team has no more than 2 coaches and 14 athletes. Each car can take 4 team members and 4 minivans, and each minivan can take 6 team members. No more than 4 minivans and 12 cars are available. The school wants to know what combinations of cars and minivans will require the minimum and maximum number of vehicles. So what we're trying, our objective is we're trying to figure out what's the minimum or maximum amount of vehicles. So when we get to that step, I'll walk you through it. For now, what I'd like you to try is what we've already practiced. Can you name the variables? Can you write out the constraints? Okay, so I'll give you a couple of minutes to try that. Okay, so let's talk out the variables. Does the number, if you think about all the things in this problem, there's lots of stuff. But does the number of players on the team change, or the number of athletes? So even though it mentions athletes and stuff, athletes are not a variable, they're fixed. Coaches, does that change? No, so you know that even though that information's given, they're not variables, they're constant. So what is it that we're talking about here that could be variables? All right, so clearly I'm boring you here. Let's move on. So C is going to be equal to cars, and M is going to be equal to minivans. So let's think about the constraints in this problem here. Can anybody, by looking at this, tell me what kind of constraints maybe they can add? Just one of them? There's a bunch in here, yeah? Right, so minivans, it says right here, no more than 12 minivans are available. So the minivans has to be less than or equal to 4. And it says the cars has to be less than or equal to 12. So, you know, in your notes you could check that off because you know you've already used that information. Okay, so I'll give you guys, those are probably the easier ones to get. I'll just give you a couple minutes to chat with your neighbor and see if you can figure out what the other constraints in the problem are. I can actually hear some of the stuff coming out, so I know some people are getting the hang of this. A lot of people were trying to figure out how to make this work as a constraint here. Can anybody describe what that says? It says each car can take 4 team members and each minivan can take 6 team members. So like, use the variables M and C. Can you write up something for that?
Yes, is less than or equal to 4. Or like car seat for car seat. And then MS is less than or equal to 6.
Okay.
I'm wrong. Yeah, that's what the okay means. Yeah, you would.
What does this represent? You're absolutely right about the amount of people, but be more specific. Oh, did I switch them around? Yeah, sorry, I switched them. Say it again, Mitchell. You're even closer. You're even closer. Getting closer, but still not all the way there. You're like 98% of it. How many teams are there?
So equal to or less than 16 times 3.
So there's 48 people here. This is the maximum amount of seats that I can take. The very most, right? So that has to be less than or equal to the 48 people. Otherwise, we're taking more people than we actually have. So that's the last constraint that we're working with. If you're trying to figure out how many people you're going to seat, you want to make sure you're not seating more than the people you actually have. Now, what are we trying to optimize here? Like find the minimum or maximum amount of the number. Well, let's not use the word cars because vehicles, yeah. So the objective function here would be the number of vehicles is minivans plus cars, and we're looking for the largest or smallest value in this function. So out of all the possible combinations we come up with, the ones we want are the largest and smallest. Okay, so I'm going to do some graphing here, and let's see what we can come up with. I guess the first thing we need to discuss here is what do we want to label as x and what do we want to label as y? There's, you know, in this case, there's not really a right or wrong answer. It's just some are more convenient.
Yeah, M can be Y, because then you're left with a smaller number when you divide.
Sounds good to me. So one of the ways that you make that decision, it's easy if you know that they divide evenly. And in this case, 4 and 6 divide evenly into 48. But Michelle's suggestion is that 6 is better because it'll cut down that number 48 and make it even smaller so it fits on my graph nicer. So I'm going to put that here. This is going to be M, and this is going to be C. So if I rearrange that, okay, so 8. So here's the form that I'm going to use to graph. And I know I've got to be able to show this 4 and 12. So let me just count. I got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm probably going to have to make the scale in marks of 2. So this would be 4, 8, 12, and then 16. I'm just trying to make sure everything will fit in this picture, so the scale I'm going to use is each tick mark is worth 2. Okay, so let's put in our functions. Does anybody remember, what does m less than or equal to 4 look like? Does anybody remember? You getting the hang of this one yet? What happens when you only have a number?
Oh, it's just a straight line.
Well, technically aren't they all straight lines?
Well, it's a straight, it's a horizontal.
Horizontal or vertical. So in this case, which one is it?
Horizontal.
It's going to be horizontal because we're using that for y. So let's put that one in here. We're going to have, it's got to be less than or equal to 4. So it's going to be underneath that line, right? Now, would it make sense for us to say, hey, go all the way down here? How come? Good. It's negative, and then the other problem is we can't take fractions. Somebody said it's got to be whole numbers. So we should write that in here too. We only want whole numbered minivans in our answer. So the next one says C has to be less than 12. What's this line going to look like? It's a straight line, yeah? It's a vertical line, yeah. So there's our line there. And if it's less than or equal, which side am I shading, the left or the right side? Yeah, I want the numbers which are smaller. And again, does it make sense for me to shade over here?
No.
So we need to be specific. This is a whole number of cars only. So the last thing that I need to add in my problem is this this slope here. Or sorry, this line that has a slope. And it starts at 8. And it goes down by 2 and then over by 3. Down by 2, over by 3. So it's going to look something like this when I connect the dots. And my favorite points available, so I'm going to test 0, 0, is 0 plus 0 less than or equal to 48. It sure is, so it's going to be this part of the graph. So Where do you think I'm going to be looking then to find my possible answers?
Is a quadrilateral.
Okay. Let's be a little more specific here. Why don't I number them and see if you can tell me?
3. 1. Oh, never mind. These are middle sections.
So what number do you think we're looking for the answers in?
1.
1. And we have to be very specific about it. Remember, we said whole numbers. So if it's only whole numbers, we could only be in this area here. And it could only be, maybe I'll use a different color. How about blue? It could only be the dots. So it could only be these ones for my possible answers. Right. So now that we have a picture here, the feasible region, when you hear that word, that just means the region where the answers are, where a feasible answer exists. So that means our gray area that we just shaded in. So feasible is a fancy word for that. So the last task that we have here is what's the minimum or maximum value for the vehicles. So ideally we'd like to take the least amount of vehicles, but I guess it's an exercise to figure out what the maximum number of vehicles are. I mean, if you really want to go and kill the earth, right? But let's see. Use some logic here. How do you think we could minimize? What would you want to do realistically if you were to do this? You want the most vans, right? So if we want the most number of vans and we have 4 available, that should tell us that we want to be somewhere along the line 4 here, right? But we also need to make sure that we use the cars as well, because we're not going to have enough vans in this situation. Minivans, we have 4. That's only 24 of the people. So if I was just to use this one, there'd be 24 people without a ride, which would be awesome if it was our team, because then we'd probably win, right? But anyway, okay. So where do you think we're going to find enough? How many cars will we need to fill that gap? 4 and 6. Yeah, 4 and 6 is right here. That is 4 minivans and 6 cars. And that is exactly the least amount of cars we can take because we've used the most amount of minivans we can. So the vehicles, and I'll call it minimum, will be 4 plus 6, which is 10. So think about it again. If I want to maximize this and take the most amount of vehicles, what's your strategy going to be? Use the cars. So if I'm going to use the cars, that's as many as 12 here, right? So I want to use as many cars as I can. If I have 12 cars, is that enough to take everybody?
Yep.
Okay, so we know right there that 12 cars is going to do it. So the maximum amount of vehicles at 12. Anybody notice anything about it? Yeah, so if you don't see that right there, who knows, this might be a coincidence, but so far it's happened that the lines where they cross, that's the spots where we found the minimum here, right where the 2 lines meet, and the maximum there where the 2 lines meet. Okay, so I'm going to get you guys to walk through one. We'll get to that. But for now, what I want you to do is try working on this one, and we'll go through it as well together. So what do you think? What would you pick for variables here?
G and O.
Okay, so G and A, yeah, O for heating oil or H, either is fine. I'll use H because that's the first word. Because oil's in the word, so you could use O. So now that you know, what's going to change is heating oil and gas. See what constraints you can come up with here. Okay, so what words here, when you read all that stuff, sounds like an inequality?
Projected.
Well, projected, things can change there, but there's more like concrete, obvious, what word I'm looking for, terms that sound like an inequality. Up to. So up to is definitely something that sounds like an inequality. Okay. What about, there's another time in our problem where it sounds like an inequality. At least. So here's our these two sentences have our constraints in them. So if I have at least 2 liters of gasoline for every liter of heating oil, then which one is going to have more? There's going to be more gas, right? So if there's more gas, that means the gas has to be greater than or equal to double the heating oil. It's backwards to the way you read it, because if you think about it, if I give you 1 gallon of heating oil, twice that means I've got to have at least 2 gallons of gasoline to go with it. You can plug in your numbers to double check, right? If I said 2 gallons of heating oil, I'd have to have at least 4 of gasoline, so it meets what the problem says. Okay, the second line that we talked about, there's actually 2 constraints in there. These constraints are actually a little easier to deal with, so what do you think? Yeah, so I'll write that one down. H has to be less than or equal to, and let's do this problem in terms of millions. You don't have to write down 9 million, you can just write down 9. We'll know your units are in terms of millions. And then what else is a constraint up there?
6.
Yeah, so gasoline has to be less than or equal to 6. Now, what's the company trying to do with their, how much gasoline and oil that they produce? Yeah, maximize the revenue. So the revenue is what we want to come up with for our objective function. Can anybody describe, like let's just say I had 10 gallons of gasoline and, well actually you probably need a calculator to do this one, but yeah, I'd need a calculator to do it. So can you describe how would you calculate the revenue? Yeah, it's $11 for 10 liters of gasoline. So how'd you get that? Right. So you take the number of gasoline and you times by 1.1. And then what do you have to add to it? The heating oil. And how much is heating oil worth?
1.75.
Okay. So 1.75 heating oil and 1.1 gasoline. That'll tell us how much revenue this company makes. So that's what we would like to make the most of. We'd like to maximize that to profit the most. So let's go down here and try and graph our constraints and see where the profits show up. Is there any other constraints about the gasoline and the heating oil before we begin that might... Is it okay to be fractions? Like, can I produce 1.1 gallons? Okay, so that's okay, but there is one more thing we should probably mention. Yeah, we don't want to have negatives here, so we want to be greater than or equal to 0 and greater than or equal to 0. So the only spot I'm looking at is this top corner. Okay. So who would like to, what do you want to pick? Which one would you like to be the y? Which one would you like to be the x? What would you like to be x? What would you like to be y? You want h to be y? We can do that. Now, if that's the way you decide to do it, that's fine. But remember, that means you're going to have to rearrange this one. If you pick it the other way, you don't have to rearrange that, right? It's going to... That's okay. We'll just... No, it's fine. We'll... So this will be... Okay, fine. Okay, so this one here, we've got to put down 6 and 9. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna cheat a little bit and move my line over. So if h has to be less than or equal to 9, I'm going to have a vertical line there. And it's got to be this side, the smaller than side. And the gas has to be less than or equal to 6. So 1, 2, 3, 4, 5, 6. And it has to be below that line because it's less than or equal. And then the last line would look like this. I have a y-intercept of 0, and I go 1 over and 2 up, 1 over, 2 up, 1 over, 2 up. So it's going to look something like this. And if I check and see what the region is here, this time I'm going to need to be, let's see, why don't I pick this point right here? If I pick that one, that's the point 0, 2. How come I can't pick my favorite point?
Because it's on 0.
Yeah, it goes right through. So if you can't pick both zeros, it's nice to pick one of them as a 0. So you could pick anywhere along there, or you could pick, this would be fine too, right? One of them is still 0 here. So if you're trying to be lazy, try and keep as many zeros as you can in it. You could do 0, 1, yeah. 1 might even be better. So in my problem then, I'm going to be asking, is 2 greater than or equal to 0 if I plotted that point? And it is, so I'm going to be up here. So that means, according to our problem, we said it has to be greater than or equal to 0, so I can't go past that line. But I'm going to otherwise be anything in here, because all of those would overlap that section in gray. So let's use some common sense here. If you wanted to maximize your revenues, what are you trying to do the most? You're trying to sell the most what? Heating oil. Yeah, heating oil is worth more. So we'd like to maximize how much heating oil we have. So heating oil, the most heating oil I can sell within my problem is right here. Okay? And that is also the most amount of gasoline, because if I move to the right, that's how much the maximum amount of gasoline and the maximum amount of heating oil I could produce. If I'm not allowed to go beyond it, and if I wanted to, I could, run the plant at less capacity. But why would you do that when you can run out more gasoline? So this is going to be the point here that maximizes their revenue. So max revenue is going to be at, so that's 3 for heating oil and 6 for gasoline. So 3 million of heating oil and 6 million of gas.
But aren't they doing more than gas?
Pardon me?
Aren't they doing like?
There is more gas. Pardon me?
But right now they're selling like gas 9 oil. How much?
Right now they're selling 6 million gallons of gas and 3 million gallons of heating oil. So it still meets this constraint. Gas is greater than or equal to twice the heating oil. Now, one thing I'll tell you is if as long as you've modeled your problem properly here and you're stayed within the feasible region, everything else is, you don't have to worry about all those other things that could go wrong. It's all modeled in there for us. All right, any weirdness happened again this time? About our answer? It's still on the corner, right? Yeah, Mitchell, you got a question? How did I get this red line right here? So this is the one that I had to graph to get it. So we said that G was going to be like Y and H was going to be like X. And there's no y-intercept there, so it's like a 0. So I started at 0 and I went over 1, up 2, over 1, up 2. My what is upside down? Oh, it's just a really bad N, that's all. All right, so this is the last one. I would like you guys to work on this one. I'm going to give you a fair amount of time to do it. I want to see if you guys can come up with one on your own this time. Okay, so I see some good progress. I'm just going to put up what I saw on my walk around. So the first thing I saw people doing was race cars and sport utility. Oops. And sport utility. Thank you. That would have been... Yeah. Then I also heard people talking about the constraints. Not everybody, I think, was there yet. I'm just going to highlight some of the things that sound like constraints. Okay, so those are the clues when you read this problem. Those sound like inequalities. Those are the things you're looking to translate in your problem. So I'll give you another minute if you're not already done your constraints. But try move a step forward, graph it, and see what you can come up with for this optimization problem. Okay, so the constraints we have, can somebody give them to me? Yeah. Yep, okay, the next one. Doesn't have to be anybody else. Yeah, we can share it around. Okay, thank you. And there's one more. Yeah, the total amount of cars greater than or equal to 70. Okay, so those are our constraints. At this point, we should be, the way we've been moving, now we have enough to make a pretty picture, so we can just shade this in. What do you guys want to use for X? What do you want to use for Y? Sure, that works for me. In this case, it's if you chose differently than me, we're going to have the same answer, but our graphs are going to look slightly different. It'll be the same answers when we're done, though. Okay, so I would have R equals negative S plus 70. And if you didn't already do this, I'm going to choose a scale of 10 for mine. So this will be 20, 40, 60, and then there'd be an 80 here. All right, so the first one, this is R and this is S. So race cars have to be less than 40. So here's my line. And I have to be below that if I'm going to be less than or equal to 40. Any other constraints we should be concerned about? About race cars, anything else we should be, like, could I be down here? Got to be whole numbers, right? Rue and Sue, right? So both have to be whole numbers. The other one there says we have to be less than or equal to 60. So here's 60. And to be less than or equal to it, I have to be on this line. And then the final thing I have to do is here. So it's going to be start at 70 and go down 1 over 1. Now, it's not a bad idea to plot a lot of points here, because then I can see exactly where they meet, and that has been something of interest to us, right? If your line goes crooked, then it's going to be harder to tell where they meet up, so it's definitely worthwhile to spend the extra minute doing the extra dots. Or at least try and use a ruler or something to make your line very accurate. Now my favorite point is available, so I will test that one. Is 0 plus 0 greater than or equal to 70? Oh darn, it's not. So it's going to be on this side. So let's just see if we can pick out. There's 1, 2, 3, 4, 5, 6, 7 areas. Which? Good. Okay, so 6 is the one that we want. So this is the spot we're looking for. And we said it's only whole numbers. So it could be here, 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 here. I'll put them in. Now, one thing you should be careful of, remember we did our scale in terms of tens. So even though it only looks like I went 1 point over, I actually moved 10 points over. Everyone in the middle would also be a consideration, right? But fortunately, we're looking for the extremes. So if we're looking for cost in this case, how do you determine cost? 8R plus 12S, absolutely. So that's my cost. If I want to maximize my cost, what do you think I should keep, what should I use the most of? Sport utility vehicles. So that means I want to use as many as I can for sport utility. And I'm still trying to maximize, I want to use as many as I can for race cars. That's as many sport and as many race cars as I can possibly make. So the maximum is when I have 40 race cars and 60 sports cars, so it would be 100. I do absolute full, that's going to cost the most if I use the full capacity that I can do, 40 a day and 60 a day. If I want to minimize the cost, then who should I use the most of? I should favor race cars, right? Because they're cheaper to make. So then if I'm going to favor race cars, it's going to be somewhere in my region where I've got race cars, but if I start moving over, I'm starting to add extra cost, right? Because I'm starting to add in sport utility. So I think that one there is going to give us the most amount of race cars and the least amount of sports cars. So that would be 40 plus 30, which is 70. So remember, I have to make at least 70. So it makes sense that I use as many as I can, which is 40 for the race cars, and then the leftovers I give to the sport utility, which costs more. Okay. So that's where we're going to leave it for our lesson today. Get you guys started on homework.